This is actually what the students will be doing in the concrete module, doing some constructive destruction to explore the science of concrete. The artificial stone-like material that is used in all kinds of structural applications. You may wonder why study concrete. There are several reasons why the topic of concrete should be put into your science curriculum. First of all, it is everywhere. We find it in your sidewalks and the roadways, sewer system, skyscrapers, airports. They're light enough to put on roofs and sturdy enough to put on foundations. Concrete is also the most frequently used material. We produce over 6 billion tons per year, and that amounts to slightly over a ton for every person on this planet. Concrete is also virtually all natural. It's recyclable, so it's very environmentally friendly. Only remember not to pour any concrete down the drain. Otherwise, your janitor will be very upset with you. To convince the students of the pervasiveness of concrete, we start out with a concrete hunt. One teacher did it by showing scenes from his favorite movies and asked the students to look for concrete in these clips. Other teachers take the students through the tour of the school sub-basement or the basement. And students are always very excited about visiting these places because they realize what's holding them up. And also, these places are off boundaries to them. Of course, a mere tour of the school campus is sufficient to help them realize concrete is actually all around them. By the end of the concrete hunt, they know enough of where and how concretes are used, but they may still have lingering questions in their mind. Why is concrete used so much instead of other materials? Or what's the difference between cement, concrete, reinforced concrete, and asphalt? The subsequent module activities are designed to address some of these questions and some of their misconceptions, as well as to prepare students for the upcoming design challenges at the end of the module. The hydration of cement activity, it's a demonstration of both physical and chemical changes that occur during the cement hardening process. And what they actually study is when cement hardens, it is actually not just a physical change. It involves exothermic reaction where they can pick up how much heat is evolved, and that it's not just evaporation of water. In this activity, they also study the effect of salt and sugar on the hardening rate and see how much it accelerates or retards the hardening process. Next, students move on to investigate the effect of particle packing on the final density of concrete. Here we see 4 columns, cement, gravel, sand, and a mixture of gravel and sand. And you can see that the mixture is the densest because it takes up the smallest volume. So in the final composition of the concrete, it will achieve the highest density. And then students actually divide into different teams. They start varying these main ingredients of concrete: how much water, how much of sand, gravel, and cement, and different combinations as shown here in the final cast forms. They investigate their effect, the effect of formulations on the final strength, the fracture toughness, and whatever effects there are important. Concrete is such a brittle material that they are typically weaker in tension than compression. Let me show you an example of what happens. When you have a tension force, which is a pulling force, on a good material, nothing happens. But when you have a defect, like in a concrete, when you have lots of particles packing, this is what happens when you put on a tensile force. And here's another example, analogy of a concrete under its own force. By gravity, it will pull the concrete, and as it stretches, you can see the under part is under tension, it's being pulled. And if those were molecules, they would be pulled apart, and you would have a fracture, and sometimes maybe catastrophic. So that's why students learn to reinforce their concrete with all kinds of materials. Here's the chicken wire, fiberglass, steel wool, and other things, nails, that you can see on this table. By this point, students are prepared to launch into one of several design activities. One of them is to make strong and lightweight roofing tiles. Another one may be to make concrete frisbees or concrete canoes or any other concrete products of their choosing. This concrete module is truly a good module to enhance your science curriculum and increase your students' understanding of science and technology. It can be supplemented into chemistry, physical science, physics, earth science, and even in technical education. I have personally benefited from this module while I was building a swing set for my own kids. It's a great module and I recommend it.